Hello everyone and welcome to AI Fridays. My name is Ryan Ahmed. I'm a professor and best-selling online instructor. I've taught over 45,000 students from over 160 countries. I'm super passionate about artificial intelligence and machine learning, and I've started this YouTube channel to make it easy for everyone to dive into this incredible field. You might be asking, why should you study AI and machine learning? AI revolution is here. The technology is progressing at a massive scale, and it's everywhere. In face and speech recognition, natural language processing, such as Siri and Alexa, self-driving cars, movie recommender systems, such as Netflix, and even robotics applications. So the first reason that you need to study machine learning right now is high salary. Average salary of machine learning engineers in the US is around $114,000 a year, which is great given how easy it is to acquire the skill. The second reason is AI and machine learning are the hottest topics and most lucrative career fields to be in right now. The field is exploding with opportunities and job prospects. The third reason is it is relatively easy to develop AI models using Python. Python is the #1 programming language for machine learning and artificial intelligence, and it's the easiest programming language to learn. In this tutorial, we will learn the basics of simple linear regression, and we'll build the practical projects together that you can add to your portfolio of projects. In simple linear regression, we predict the value of one variable y based on another variable x. So why we call it simple? Because it examines the relationship between two variables only. And why do we call it linear? Because when the independent variable increases or decreases, the dependent variable increases or decreases in a linear fashion. After you complete this section, students will master simple linear regression techniques, and they will also cover the least square method theory and intuition. You'll be able to understand the underlying theory and intuition behind simple linear regression techniques and least square methods, master Python programming and scikit-learn as applied to simple linear regression, apply simple linear regression techniques to predict product sales volume, and learn how to divide datasets into training and testing using scikit-learn. We'll also learn how to evaluate the model and assess its performance. I hope you will enjoy this tutorial. Hello everyone and welcome to this lecture. In this lecture, we're going to cover the basics and intuition of simple linear regression. Okay? All right, so let's get started. So in simple linear regression, we wanted to predict the value of one variable y based on another variable x. Okay? And in general, we call x the independent variable and we call y the dependent variable. So why it's called independent? It's called independent because you simply can change it on your own in an independent fashion. Simply, you can just give it whatever value you want, and our objective when it comes to simple linear regression is to obtain that relationship between these two variables, x and y. I change x independently, and then based on my simple regression model, I can predict the value of y accordingly. That's all what it is. So the first question is why it's called simple, and the second question is why is it linear? It's called linear too. So first, it's called simple because it examines the relationship between two variables only. So we only have x and y. However, when we move forward in the course, we're going to cover more advanced regression techniques, and we're going to have, we'll call it multiple or multi-linear regression models, where we have more than two variables. Okay, so we can have, let's say, 3 independent variables, for example, and 1 dependent variable. The next question is why linear? It's linear because when the independent variable increases or decreases, the dependent variable increases or decreases in a linear fashion as well. Okay? All right. So let's assume that, all what I've just described right now is not clear. So let's take a look at a practical example. Let's assume that you are a business owner and you own, let's say, an ice cream cart. Okay, very simple example. And as a business owner, you wanted to develop a relationship between the outside air temperature and the daily revenue that you get out of your business, out of the cart.
So what you did, you said, you know what, let's go ahead and let's say during the entire year, I'm going to be collecting data points. When the temperature outside was 24 degrees C, my revenue was around $534 a day. And then another day, you picked up the temperature again. Then the temperature, let's say the average temperature throughout the day, was around 26 degrees C. And then the revenue was around $625 a day, and so on. And basically what you wanted to do is to develop a mathematical model in which at any given day, you wake up in the morning, you get a guess, or you actually measure the outside temperature, and then you can predict what my daily revenue will gonna be at the end of the day. That's all what it is. And that's where all the simple linear regression strategies comes into play. Okay? All right. So let's go ahead and actually plot these data points. So here we have on the x-axis, we have our temperature in degrees C. And on the y-axis, I have my revenue. And what I'm going to do is that I'm going to basically plot all the data points, the temperature and the revenue, as you guys can see here. Okay. So we plotted the data points for each of the temperature versus the revenue. So when, for example, the temperature was 24, revenue was $534, you just went there, temperature was 24, and the y-axis or the revenue was around $534. And as I mentioned, our objective is to get this straight line, which is what we call it the best fit line. This is the line that can best describe the data points. It can best fit the data, okay? All right. So that's it. That's all what simple linear regression is. It's very simple, just a way of getting a relationship between two variables, x and y, and that's all what it is. Okay? All right. So let's take a look at some mathematics. So again, here I have my temperature, I have my revenue, I plotted all the data points, and my objective, as I mentioned, is to obtain this line, the best fit line that can go through the data. And if you guys recall from basic mathematics, that an equation of a straight line can be represented as follows. Y equals to b plus m times x, where x is called the independent variable, which is in this case temperature in degrees C, which is simply I can just change it independently on my own. And y is called the dependent variable, which is in this case we're going to be revenue. And my objective is to try to obtain the values of m and values of b. And when I obtain the values of m and values of b, that's it. Now I have a simple linear regression model. That's all what it is. So when I say I wanted to develop a mathematical model, that means what I'm looking for is to obtain the values of m and b. That's all what it is. Okay? All right. So one important feature when it comes to simple linear regression is that once I obtain the equation of this straight line, I can then describe or just predict the amount of change in my daily revenue compared to the change in my temperature. For example, now I can know for each 10 degrees rise in temperature, this will be equivalent to, let's say, $20 increase in revenue. So now I can know the impact of my temperature on my revenue, which is very important. Okay. Again, please bear in mind that this example is very simple example, and that's why it's called simple linear regression. In this course, we're going to cover a lot more advanced topics, such as artificial neural networks and multiple linear regression and polynomial regression and so on. But this is the foundation. This is the core basics and intuition that I want you guys to understand. All right. So the question is, how are we going to use the model? So, okay, once I obtain m and b, okay, and so what? So again, as I mentioned, now I have an equation, y equals to mx plus b. X is my independent variable, y is my dependent variable. As you guys can see here, once the coefficients m and b have been obtained, and again, m is simply the slope of the line, which is delta y divided by delta x, and b is simply the y-intercept, which is how much did I intercept here with the y-axis. That's all what it is. These are the parameters m and b. Once I obtain this equation, once I obtain this straight line, and once I obtain these values of m and b, then I can use the trained model moving forward to predict any revenue in dollars based on the outside air temperature. Simply put, now I can come on any given day, for example, let's say measure the temperature, let's say 45 degrees C, I can go up, and I can predict the revenue will be $1,000, okay? Even though, and that's very important, this temperature might not be seen before by the model. And that's the beauty of machine learning in general, is that I've used a couple of data points to come up with this fit. And that's what we call it the training data, okay? And then I can deploy that model, which is that blue line in here. I can deploy it in practice to predict future measurements or future values that has never been seen by the model before, which is very, very powerful, okay? Which means I can come up with a new temperature, maybe 60 degrees, for example, like on a crazy, day, and then I can predict revenue, let's say, to be 1,200, which is, we never had these as data points beforehand. Okay. So now it's time for a mini quiz, okay, or a mini challenge. Now I have two equations. The first equation is y equals to 3 times x, and the second equation is y equals to 15 minus 10x. And here I have two graphs. This is the first graph and the second graph. And what I want you guys to do is to please go ahead, pause the video, and I want you to match each of the equations with the graph. So does this equation match this graph, or this equation must match this graph? And please explain to me why did you come up with this answer. Please go ahead, pause the video, and I will see you guys after the challenge. All right, I hope you guys were able to figure out the challenge. What I ask you guys to do is to simply match the equations with the figures. So as you guys can see here, y equals to 3 times x. This simply matches this graph. Okay, for two reasons, okay? The first reason is, if you try to match it with our equation, with our regular straight line equation, y equals to m times x plus b, right? First, I don't have b value, which means b in this case equals to 0. Which makes sense in here because now my straight line passes through the origin, which means there is no y-intercept. And that's why b is 0 in this case. That's the first point. The second point is the m, which is the slope of the line, is positive. It's positive 3, which means as the independent variable goes up, the dependent variable will gonna go up as well, or gonna increase as well. And this basically is explained with this model, with this line. As x increases, you go up and your y increases as well. All right? Okay. What about the other equation? If you take a look at the other equation, you will find that y equals to mx plus b. And in this case, there is a y-intercept, which is 15. So now this distance must be 15. And as you guys can see here, this straight line simply the slope here is negative, which means as x goes up, as x increases, you will find that simply the y goes down, which means there is an inverse relationship between the two. And this is simply explained by the negative sign in here. That means I have negative slope, which means they are inversely proportional to each other. All right, okay. I hope you guys were able to figure out the quiz. And for those of you guys who are interested to read more or to have an additional reading material, these are two great books I highly recommend. The first book is called Understanding Machine Learning. And in page 123, again, all these books are free to download. You guys please go ahead and download it for free. And we have another book, which is an introduction to statistical learning. And here there is page 61. Please go ahead, check them out, and you will find a ton of information. Please bear in mind that in this course, we're not going to dig a little bit any deeper into the mathematics. We're just going to cover the intuition, cover the basic math, and then we're going to see how can we apply it and deploy it in practice. And that's the most important part, okay, is to actually understand how can you apply it, in your daily life, for example, or at your job, for instance, okay? All right, and that's all what I have for this lecture. I hope you guys enjoyed it. In the next lecture, we're going to cover the least squares, which is the strategy that we're going to use to obtain the coefficients m and b. Let's recap what we have done so far. In this lecture, we cover the theory and intuition of simple linear regression, and we learned that we are going to obtain a simple relationship, a straight line equation, between two variables, an independent variable x and a dependent variable y. And as I showed you guys, that the equation is simply y equals 2 m times x plus b, and the overall objective is to obtain the best values of m and b. And that's it. Once I have my model, then I can deploy it in practice to predict revenue or in dollars given a certain temperature. And that's it. We went through a quick quiz and additional reading material. And that's all what I have. Best of luck. Stay tuned, and I'll see you guys in the next lecture. Hello everyone, and welcome to this lecture. In this lecture, we're going to cover a technique that's called least squares. And it's a very important technique that can be used to optimize our simple linear regression model and obtain the best fit to fit the data points. So let's recap what we have done in the previous lecture. In the previous lecture, we covered the basics, theory, and intuition of simple linear regression. And we simply cover that we're going to obtain a relationship between two variables, an independent variable x and a dependent variable y. And simply, what we wanted to do is to obtain this equation. We wanted to obtain the best coefficients or best model, or m and b, that can best fit my data points. That's all what it is. All right. So let's take a look at the least squares. Okay, so what we're going to do here is that let's assume that we have, again, the same data points. Here we have my temperature on the x-axis. Here I have my revenue on the y-axis. Here I have my data points. Okay, and what least squares we're going to do is least squares simply is a way to find the best fit curve or line for a set of points. So now I have a couple of points, and I want to get the best line that can go through the data. So first, what we're going to do, we're going to say, you know what, let's come up with this line, okay? Just a random line. And what we're going to do is that we're going to calculate the error or the difference simply between each of these basically data points that we have and between the actual true points that we have here. So as you guys can see, I simply have two parameters or two values. What we call it y actual, okay? And these are the ground truth. These are the true data points. These are the actual points, these points, 1, 2, 3, 4, 5, that came up. You know, I actually went out there in the field and measured data points. I measured temperature, and I calculated how many dollars I have at the end of the day. These are the actual points. And these are the actual points that I have here. And this model is what we call it the prediction. These are the estimated points, okay? And that's why here we call it yi hat. So hat indicates this is an estimate, okay, kind of a guess per se, or prediction. And the yi, these are the true points. These are the true values. And what we're going to do to assess the performance of that model is to simply calculate the error or the residual. We call it the residual. So the offset is simply, or the error distance d, would be the difference between the actual point, which is yi, minus yi hat, as you guys can see here. What we're going to do, I'm going to show you that we're going to obtain the absolute, so technically the sign won't make much of a difference. So now I have yi hat minus yi, where I indicates the index of the data point. So this, for example, might be y1, this is y2, y3, y4, and y5. Okay? All right. So that's the first step. And what we're going to do afterwards is that we're going to say, you know what, we're going to go ahead and calculate all the residuals. So we're going to get the residual for the first point, residual for the second point, for the third point, and so on. And what I'm going to do is I'm going to take the error, square it up. So we're going to square it. And that's why it's called squares, sum of squares. So I squared it up just to remove the sign and magnify it as well in a way. And then I'm going to sum them up. So I'm going to sum up all the error squared across every single point. And I'm going to obtain the minimum value, just the minimum value out of all of it. And that's it. Now we have been able to obtain the least sum of squares. So simply put, I'm just going to calculate the residual for each point, square it up, sum them all, and then obtain the minimum value. That's all what it is. All right. So that's it. That's basically what least sum of squares technique is going to do. And I'm going to show you in scikit-learn, we're just going to use one simple command that can do all the magic for us. We don't have to actually go and do any major programming or writing the code from scratch. So the next concept that I wanted to give you just to demonstrate is that in general, when we have the data, we collect the data. Let's assume that we collected, for example, 100 samples. What we do in general is that we divide the data into two sets. What we call a training set and a testing set. And in general, we use, let's say, for example, here, 25% for testing and 75% for training, okay? And we're going to use the training set to simply train our model. So we're going to grab the model, feed in these 75 samples, try to train it to make it, like learn the input-output relationship. And then afterwards, and this is very critical, once we have our trained model, we're going to take our trained model and then test it or deploy it basically in practice. To do that, we're going to use the rest of the data points, which is 25 testing samples, to actually test the performance of the model. So we're going to use the testing data set to test trained model. And a very important note here is that please make sure that the testing data set has never been seen by the trained model before. And this concept is extremely important, okay? So again, when you go ahead and test a trained model in practice, the training data, okay, the testing data should not be seen by the model during training, okay? And that's the idea of trying to develop a machine learning model that can be able to generalize in practice, okay? All right. And if you guys wanted to have additional reading material on least squares, you can simply check, again, these two books. They are free to download. And if you check page 124 and page 62, you would be able to find a ton of information, ton of mathematics. And that's it. That's all what I have for this lecture. I hope you guys enjoyed it. Let's recap. So in this lecture, we cover the basics of least square, or sum of least squares, which is simply a technique to try to obtain the best fit line by calculating the residuals or the error of every single point, squaring it up, sum them up, and then obtain the minimum value, okay? And then we learned that we're gonna divide the data into training data set and testing data set, and we're gonna train the model using the training data, take the trained model, and then test it using the testing data set, which is, in general, we use 75% for training and 25% for testing. And that's all what I have for this lecture. I hope you guys enjoyed it, and see you guys in the next lecture. Hello everyone, and welcome to this new lecture. In this project, we're going to learn how can we apply simple linear regression to predict the revenue of an ice cream stand given the temperature or outside air temperature. It's pretty much kind of consistent with the simple linear regression intuition. It's pretty much the same example, but we're going to use kind of an extensive data set that we are going to generate. I'm going to see how can we use it to train our model, okay? Okay, so in this lecture, I was going to walk you through an overview of the problem statement, and then I'm going to walk you through the key steps that we're going to be following, and then in the what we're going to do is we're going to start coding the actual project step by step moving forward. Okay, so let's go ahead for the problem statement. So let's assume that you own an ice cream business and you would like to create a model that would predict the daily revenue in dollars based on the outside air temperature in degrees C. You decided that a linear regression model might be a good candidate to solve the problem. All right, so what's our data set? Our data set consists, again, of, if you guys recall, we generally have two variables, our independent variable x and our dependent variable y. So our independent variable x, in this case, is our outside air temperature, and our dependent variable y is our overall daily revenue generated in dollars. All right, so what we're going to do, we're going to go through kind of a series of steps to build our model together. The first step is we're going to import all our libraries, such as pandas, numpy, seaborn, matplotlib. I'm going to walk you through what do you mean by all of this and why do we need them. And then afterwards, we're going to import our data set. Okay, so the question is, where is our data set? So the data set, if you guys go to the course material, to the course package, under simple linear regression, you will find mainly our ice cream data, and that's our ice cream data that we're going to be using, which is our CSV data. Let's actually open our file and let's take a look at it. All right, so when you open the file, you guys will gonna find simply here that we have two columns. All right, so we have one column is the temperature, and the second column is revenue. And that's basically the data we're gonna be relying on to obtain our simple linear regression. If we scroll down, you will find that we have maybe 400 or maybe 500 samples, 500 data points almost, 500 samples. Okay, sounds great. Okay, so after we load the data set or import our data set, we are going to visualize our data set. So we're going to use Seaborn libraries and maybe Matplotlib to do some visualization to the data. And then step 4, we're going to create our testing and our training data set, simply dividing the data into training and testing. If you guys recall, we simply divide the data into, let's say, 75% for training and 25% for testing. Afterwards, we're going to train our model in step 5, and then afterwards we're going to test our model in step 6, and afterwards we're going to simply conclude our project. And that's pretty much all what I have for this lecture. I hope you guys enjoyed it. Let's recap what I've done so far. In this lecture, I just walk you through the problem statements and along with the data set we're going to be using, along with the 6 key steps that we're going to follow to build our project. All right, okay, in the next lecture, I'm going to walk you through the first 2 steps. We're going to see how can we import our libraries and import our data set. And that's pretty much all I have for this lecture. Hope you guys enjoyed it. Best of luck, and I will see you guys in the next lecture. Hello everyone, and welcome to this lecture. In the previous lecture, I walked you through the problem statement for our simple linear regression. And we have realized that we have simply a data set that consists of 500 data points and consists of mainly 2 variables. Our independent variable x, which is our outside air temperature, and our dependent variable y, which is our overall daily revenue generated in dollars. All right. So what we're going to do in this lecture, we're going to, first step, import all our libraries. Second step, import our data set. All right, so let's get started. Okay, so if you guys wanted to, you have 2 options. So first step, you either can simply go ahead and create just a blank, mainly Jupyter notebook, and start building our project together. Or you can simply go ahead here to simple linear regression, ice cream revenue prediction notebook. And that will kind of contain all the solution basically for the entire project. Again, here, all this and along with the data is contained in our simple linear regression folder. All right. Okay. So let's get started. Let's assume that we have a blank page. I'm going to start from scratch. To add new cells, what we're going to do, we're going to press A. So when you press A on your keyboard, that will add new cells. And what we're going to do, we're going to import all our famous libraries. So we're going to say, okay, import pandas as PD. We're going to use Panda mainly library for data frame manipulations. Think of pandas as kind of an Excel in a way. So we're going to load, for example, like a table, manipulate tables, pretty much works in its exact same fashion as Excel. All right. Afterwards, we're going to import NumPy as NP, and NumPy mainly used for numerical analysis, and I'm going to be using it extensively pretty much throughout the course. Afterwards, we're going to import 2 important libraries that we're going to be using to perform data visualization. The first one, so we'll call it Matplotlib. So we're going to import Matplotlib dot pyplot as PLT, and we're going to import the last one, Seaborn as SNS. Okay, so Matplotlib mainly used for data plotting. So if you want to visualize the data, we're going to use Matplotlib. And we're going to use as well Seaborn, and think of Seaborn as kind of an advanced form of Matplotlib. It's actually really like powerful library. We're going to be using it again throughout the course to plot really powerful and statistical data in a very powerful, intuitive way. All right. So to run the cell, what we're going to do, we're going to press Shift Enter to run the cell. So Shift Enter. That should run the cell, and here we go. So now the cell is ran. So when it has asterisk, that means it's running. When it's 1, that means, or 2, or whatever index, that means the cell ran successfully and everything looks good. Okay. Let's go ahead and actually delete these cells. To delete the cells, just press D DD, double D. So you press double D will remove, double D will remove. All right. The next step that we're going to import our data set. So again, I wanted to insert new cells. So I'm going to come here and press A. So again, A to insert new cells. And what we're going to do, we're going to import our ice cream data.csv. If you guys recall, our data is contained in here into ice cream data CSV file. So let's go ahead and use pandas data frame to actually read our data. So first, I'm going to create a data frame, and then I'm going to call it ice cream. So I'm going to say ice cream equals to PD, which is our basically pandas here data frame they're going to be loading, mainly our library they're going to be using. So we're going to use pd.read underscore CSV. And here we're going to pass along or list exactly the name of our CSV file. So again, it's called ice cream data.csv. All right. If you're not familiar with mainly read underscore CSV, basically we're going to use pandas data frame to read our CSV file. And here we're going to list the exact same name of the CSV file. If you guys recall, go here. This is our ice cream data. Please make sure that I is uppercase, C is uppercase, and D is uppercase. And please make sure to include .csv as well. Okay? All right, let's run it. So shift enter. Here we go. As long as you didn't find any error, that's a good sign. Okay? What we could do afterwards, we could say, okay, ice cream, which is our data frame. Simply, this data frame contains all the information. That's all the data that we need right now. So what we could do, we could say, okay, ice cream dot head, okay? And let's say we're going to visualize 5, for example. When we press shift enter, here we go. You will find that when you apply the head mainly method, what we could do is that we can simply visualize kind of, a list of data points. So when I say ice cream dot head 5, that means I wanted to visualize or view the first 5 samples. So if you guys can find here, we have our temperature and we have our revenue. So for example, when the temperature is 24, revenue is $534. When the temperature goes up to 26, revenue goes up to $625. When the temperature goes to 27, the revenue went to $660. And when the temperature went down to 20, the revenue went down. So it seems like there is a linear kind of, proportional, directly proportional relationship between the temperature and the revenue. All right, and that's the objective of our exercise. We'll see how can we do that. So what I want you guys to do is to please go ahead, pause the video, and I want you to visualize the first 10 samples within our data. So instead of visualizing 5, I want you to here, right in this cell, just the exact same pretty much command, but visualize 10 samples instead of 5, okay? Please go ahead, pause the video, and I will see you guys after the challenge. All right, I hope you guys were able to figure out the challenge. What I ask you guys to do is to simply call the data frame, which is ice cream data, or ice cream, sorry, my ice cream data frame. We're going to say dot head, and we can pass along here. I wanted to visualize the first 10 samples, right? So I put 10 instead of 5. When I press shift enter, here we go. So now I've been able to visualize the first data points, 10 data points instead of 5. All right, looks great. Okay. What if I wanted, for instance, to, let's say, visualize the last couple of points? Let's say five samples, last 5 samples. So what I could do, and instead of using head, I'm going to use tail instead. So I'm going to say ice cream dot tail, and here I can pass along, let's say 5. Okay, press shift enter, here we go. So now I've been able to visualize the last samples. If you guys take a look here, you will find here we have 499. That's kind of the index of my data. And you'll find here that we have started with 0. We ended up at 499. So we have around 500 data points. Okay. All right. So what I want you guys to do, again, that's a mini challenge. Please go ahead, pause the video, and attempt to visualize the last 10 data points. So instead of visualizing 5 data points, I want you to visualize the 10 data points. Please go ahead, pause the video, and I will see you guys after the challenge. All right, I hope you guys were able to figure out the challenge. What I ask you guys to do is to simply do, again, our data frame, which is ice cream dot tail, and I wanted to visualize the last 10 samples instead of 5. So it's just going to say 10 instead of 5, and then I press Shift Enter. Here we go. And now I've been able to visualize the last data points starting from 490 up till 499. All right, sounds great. Okay, so what if I wanted to, let's say, maybe visualize the entire data frame? I want to take a look at it, the entire thing. Well, I'm not going to be using head, and I'm not going to be using tail. I'm just going to say ice cream, and that's it. Press Shift Enter. Here we go. So that's basically my entire data frame. So when I say ice cream, it will show starting from 0, going down, all the data, and you will find that there is dots here indicating, there is missing data. Not missing, but the data. They can't visualize, obviously, the entire 500 samples. So you only visualize the first 30 samples, and they visualize the last 30 samples too. So 470 going down, 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 up to 499. And the beauty about kind of Pandas data frame, it can show you as well the number of columns, the number of rows. So here I have 500 rows, which makes sense because I have 500 data points, and I have 2 columns in here indicating the input and the output. All right, so let's go ahead and do a little bit more of analysis. What we could do, we could say, okay, maybe get my data frame, which is my ice cream. And what we could do, we're going to say dot tail All right, so let's go ahead and do maybe a little bit further analysis. What we could do, we can say, okay, ice cream dot, and we can apply what we call it the describe way of doing it. Let's see how can I do that. If we apply describe and we open parentheses here, just empty parentheses, press Shift Enter, here we go. Again, this is really powerful because it just kind of give you like an amazing summary in one-stop shop of the data without doing any analysis. This kind of giving you a statistical just summary. So it's telling you, okay, so for the temperature, we have 500 samples, 500 data points. For the revenue, we have 500 data points. The mean values was around 22. That's kind of the mean for the temperature. For the revenue, we have the mean revenue is around $521 a day. The standard deviation is around 8. The standard deviation is around 175. If you guys don't recall, standard deviation is mainly the dispersion from the mean. That dispersion from the mean is like a little bit small. That means kind of, if we have a normal distribution data, that means the actual bell curve will gonna be kind of very tight. If our standard deviation is large, that means the dispersion from the mean is large. That means the data or the curve will gonna be very wide in a way, okay? That means the data is dispersed. All right. Here it indicates the minimum and maximum. So the minimum is ranged from 0, the maximum is 45, that's our temperature. And the revenue is ranged from minimum was $10. So when the temperature, let's say, is 0, indicating, for example, let's say that we have a very cold day, we're gonna make it only $10, maybe sell like 2 or 3 ice creams, for example. However, if the temperature is 45 degrees C, that means it's really high, our outside temperature, then we're going to collect way more revenue. We're going to collect maybe $1,000 or so. All right, which makes sense. Okay, sounds good. And here it shows you the 25 percentile of the data, 50% and 75%. And that's here the kind of the data shows 17. So from 0 to 17, and then 22, and then 27, and then the max is 45. Here from 10 to 405, and then 529, 50%, and 75% was around 642. And then we have here our maximum is around 1,000. All right. One more analysis before we conclude this lecture. Let's go ahead and do ice cream, which is our data frame, .info. And again, info is really powerful way of actually kind of visualizing the data in a way. So here it's showing you, okay, our range is 500 entries, range from 0 to 499. We have 2 columns of data, mainly their temperature and their revenue. They are 500 samples each. Each one is float 64, and we have non-null elements. Actually, that's a good point. Non-null, that means we don't have any missing data. And that's kind of, an easy way of dealing with the data. In general, in practice, when you go outside and let's say collect data or look at data, for example, on like Kaggle or any of the famous websites, you will find there's a lot of data that's actually being missing, okay? And you need to, which means that you will find null data, maybe like this number is missing. I need to do some feature engineering to try to fill out this data. But here, this is just kind of, ramping up example. We don't have much to perform data analysis. It's very easy data, just 2 data points and so on. And here, if you guys take a look at it, you will find the memory usage of the actual data frame is around 7.9 kilobytes. Okay, and that's pretty much all what I have for this lecture. I hope you guys enjoyed it. Let's recap what we have done so far. In this lecture, we have been able to simply import all our libraries. So we're able to import pandas, NumPy, Matplotlib, and Seaborn. And we're able as well to visualize or import the data set. So we imported our data set in a data frame, which is ice cream. We'll be able to visualize the first 5 data points, first 10 data points, the last 5 data points, and the last 10 data points. And we've been able as well to visualize the entire data frame by just calling the data frame. And we've been able as well to take a look at using the describe and using the info to just give us kind of a quick summary of the mean, standard deviation, and so on, along with the info here showing if we have any null elements or not. All right, and that's pretty much all what I have for this lecture. In the next lecture, we're going to proceed with our project and start to visualize the data and create testing and training data set. Best of luck, please stay tuned, and I'll see you guys in the next lecture. Hello everyone, and welcome to this lecture. In the previous lecture, we were able to load our data set and we're able to do just a quick short analysis on our data. So if you guys recall, we had our data, which is ice cream data.csv. We're able to use pandas .read CSV to actually read our data frame. And now we have a data frame called ice cream that consists of 2 columns, temperature and revenue. And we're able to visualize our first couple of samples, our first couple of rows, 10 rows, and the last 5 rows, and the last 10 rows as well. And we're able as well to use describe and info just to give us kind of a quick summary, statistical summary of the mean, standard deviation, min, max, and so on. And we'll be able as well to visualize some of the information. And we have found that we don't have any null elements in our data, which is great. All right. Now to the fun part. Now I'm actually getting really excited. So let's see how can we do that. Let's go ahead and actually visualize a couple of the data set. All right. So let's insert a couple of new cells. So again, press A to insert new cells. And let's go ahead and use SNS or Seaborn to plot a couple of the data points. All right, let's get started. So what I could do, I could say, okay, SNS dot joint plot, okay? And then in joint plot simply takes variable X, variable Y, and I need to specify the data source. Okay, so what I wanted to do, on the X-axis, I wanted to basically plot our temperature. If you guys recall, this is our data, right? So we had temperature, that's my first column, and revenue, that was my second column. So when I say SNS to join plot, here I specify X equals to temperature, that's my temperature value, and then Y equals to, here I'm specifying my revenue, which is my second column. Please make sure here that the first letter R was uppercase and first letter T was uppercase as well. Afterwards, okay, they need to specify what is the source of the data. So what's my data? Data is simply coming from my data frame, which is ice cream. Let's copy it, let's paste it here. And maybe we can specify the color here. Let's say I like the color gray maybe, so let's specify color gray. All right, okay, looks great. Shift enter. And here we go. Here is our beautiful data. All right, looks great. So if you guys take a look at it, first of all, first observation, maybe there is a linear line that can go through all the data, which looks great. Okay, on the X-axis here we have our temperature that goes from 0 up to, let's say, 50 degrees C. Our revenue that goes from 0 going up to almost $1,000 a day. And here we have kind of a little bit of distribution for our temperature and as well distribution for our revenue. So it shows like maybe there is like a normal distribution and, you know, the mean is around, let's say, 25 degrees C. And the mean here, let's say, is around maybe $500 or so. All right, looks great. Okay. So the next step that we could do here, which is what I want you guys to do, is to please go ahead, pause the video, and I want you to, instead of plotting the temperature versus the revenue, I want you to plot the revenue on the x-axis and the temperature on the y-axis instead. Again, we're going to use join plot as well, pretty much the same, but please go ahead, just change the data somehow or change that command somehow to make here the revenue and make here on the y-axis the temperature instead. Please go ahead, pause the video, and I will see you guys after the challenge. All right, I hope you guys were able to figure out the challenge. What I ask you guys to do is to simply copy this and paste it here. And simply, instead of making this a temperature, we're going to make this revenue instead. And please again, make sure this R is uppercase. And here, instead of having revenue, we're going to set that to temperature. All right, looks great. Maybe we can make it a different color maybe and set it to blue, for instance. All right, and shift enter. Here we go. All right, looks great. So now we have our revenue on the x-axis. Now we have our temperature on the y-axis. And here we have our mainly again data points. And again, we have our distribution, which looks great. All right, I hope you guys were able to figure out the challenge. Okay, all right. The next visualization, we're going to use as well Seaborn library. But we're going to use a very powerful tool within Seaborn, is what we call it pair plot. Let's see how can we do that and what's useful for. What we're going to do, we're going to say sns.pair plot. And what I need to do is just pass along our data frame. If you guys remember, all our data frame is called ice cream, which is here, right? So that's simply our data frame that contains all the data. So we're going to say, okay, please do pair plot for ice cream. Shift enter. Here we go. All right, what's beautiful about pair plot is just you can plot tons of information just using one single command. sns.pairplot, pass along your data frame, and you will come up with pretty much all the combination of the data. So if you guys can see here, you will find here is the temperature versus our revenue, and this is our data points. Here we have our revenue versus our temperature, and here is our data points. And this is pretty much a distribution for the temperature and for the revenue. Again, as we mentioned, the temperature distribution ranges around, let's say, 20 degrees C, and the revenue here is around, let's say, $500 a day. If you guys take a look, a quick kind of, deep look into it, you will find that this curve, which is revenue on the x-axis versus temperature, and this curve, which is temperature versus revenue, we have already done that before. We actually have done that in the challenge here, when we plotted the revenue versus temperature. And we have done that here as well when we plotted the temperature versus revenue. So instead of using join plot several times, what you could do, you could say, okay, let's go ahead, do pair plot, and it will just gonna take care of everything in just one single shot. And that's the beauty of it. All right. Okay. Let's go ahead and do one more visualization, okay, before we conclude this lecture. What I ask you, let's see how can we do that. What we could do, we can say, okay, sns.lmplot, and we can pass along x equals to our temperature, and we're gonna pass y equals to our revenue, and we have to specify our data, which is simply our data frame ice cream. All right, so what's the point of lmplot? What's beautiful about lmplot? It's just a very quick way to plot the best line, or kind of like a straight line that goes through the data. All right, so if you press shift enter, you will come up with basically again all the data points that we have, which is our original data set, and we have a straight line that goes through it. Okay, so again, instead of running any optimization or any sum of least squares or any of that complicated stuff, you can just use sns.lmplot, and it will just gonna do the magic for us. And it will just plot the best line that go through the data. And that's pretty much how can we use Seaborn to just give us a quick overview. Okay, would a straight line be a good fit for the data or not? Okay, all right. So now again, it's time for a quick challenge. What I'm asking you guys to do is please go ahead, and instead of getting the straight line for the temperature versus revenue, I want you to do it the other way around. I want to do the revenue versus temperature, and to try to visualize again, see if a straight line would best fit the data or not. Please go ahead, pause the video, and I will see you guys after the challenge. All right, I hope you guys were able to figure out the challenge. What I ask you guys to do is to simply copy this command, paste it here. So again, we're going to use lmplot as well, but instead of passing temperature, we're going to pass revenue instead, and instead of passing on the y-axis revenue, I was just going to pass temperature instead. That's it. That's how you do it. Shift enter. Here we go. So now we have the revenue on the x-axis. Now we have the temperature on the y-axis. And here we have kind of the best fit line that can go through all the data, which is really powerful. All right. Okay, and that's pretty much all what I have for this lecture. I hope you guys enjoyed it. Let's recap what we have done so far. In this lecture, we have been able to visualize our data set. So we've been able to use join plot and passing along our x-axis and our y-axis data. We're able to visualize our data points, which looks, like a linear line, would be a great fit for it. We have been able as well to, in the mini challenge, to use join plot. And instead of plotting the temperature versus revenue, here I was able to plot the revenue versus temperature. So we plotted revenue versus temperature. And then we have been able to use pair plot to just plot basically all the combination of the data. So we're able to plot temperature versus revenue versus temperature, and so on, along with the distribution. And then we have been able as well to use lmplot to actually draw the kind of, a straight line that goes through the data without doing any optimization, without anything. And here as well, we have been able to, in the mini challenge, use the lmplot, but instead of using temperature versus revenue, here we used revenue on the x-axis versus temperature on the y-axis. All right, that's pretty much all what I have for this lecture. I hope you guys enjoyed it. In the next lecture, we're going to learn how can we create testing and training data set, and we're gonna go ahead and also train our model. Best of luck, and see you guys in the next lecture. Hello everyone, and welcome to this lecture. In the previous lecture, we have been able to perform some data visualization using Seaborn library. So if you guys recall, we have been able to use join plot to visualize our temperature data versus our revenue data. And we've been able as well to use pair plot to just kind of, plot all the variables together in one stop shop. So if you guys can take a look here, you'll find the temperature versus revenue versus temperature, and so on, along with the distribution of each of the two variables. Afterwards, we've been able to use lmplot to draw the best line that can fit the data, which is our temperature and revenue. And again, without doing any analysis, without doing any training, that was kind of, very quick kind of visualization tool to see if a straight line would be a good fit or not for the data, which is obviously yes in this case. All right, so let's take a look at step number 4. So what we're going to do in this lecture, we're going to create testing and training data set, and let's go ahead and actually divide our data set as well into training and testing. All right, let's get started. So first of all, as kind of a standard when we do machine learning in general, we divide the data into X and Y, where X is our inputs and Y is our targets or our output. So if you guys recall, maybe go ahead and actually visualize our ice cream again. So we're going to say ice cream, which is our data frame, shift enter. And you guys can find that here we have two columns, which is our temperature, and here we have our revenue. All right. So what we could do, we know that temperature is our independent variable. So that's my X or my input to the model. And revenue is my predictions, or is my output, or is my target class, for example, right? That's so input, that's my output. So let's go ahead and name them. So what we could do, we could say, okay, X equals to ice cream. And here we're going to pick our temperature. Okay, so shift enter. So that will be the value of X. Let's take a look at it. So if we do X, shift enter, you'll come up with that column, which is temperature, and that's my input to the model. That's my independent variable. Okay, that's good. And again, if you guys take a look at it, you will find that there are 500 rows by 1. All right, so if you take a look at the output Y, so Y equals to ice cream, and here we're going to pass the revenue instead, which is my output. So if you guys recall, this is my column, which is my revenue, and that's my output, right? So let's go scroll down. Here we go, shift enter, and let's take a look at Y, and here we go. So now I have, that's Y, that's all my outputs, which is again all the expected dollar values. So now I'm pretty much ready. First of all, because the data is actually, we don't have any null elements, we don't have any data that's missing, so that's a good sign. So we're now pretty much ready to go ahead and actually divide our data set into training and testing. And to do that, we're going to use Sklearn library to perform that division. So let's go ahead and do it. So we're going to say, okay, from sklearn dot model underscore selection, we're going to import train underscore test underscore split. Shift enter. That's first step. So basically what we have done here, that we imported our train test split class, and that class is kind of responsible for dividing the data into whatever ratio that we're going to be doing. And let's see how can we do that. What we could do, we could say again, all right, train underscore test underscore split. And if you press shift tab, that will show us basically here how can we use train test split to our advantage. It just show you that basically what it does, it just divide or split the data, and it performs the shuffling as well, which is really powerful. It simply like split the data into whatever percentage, all right, into let's say 75% training, 25% for testing. And the beautiful thing about it too, is just does the shuffling, which is really powerful when it comes to machine learning. So what it does is just, like change the order of the data, and I will show you exactly what do we mean by this. And if you want to see how can you implement it, you can actually scroll down, and you will find that there is an actual example here, which is really powerful. So if you guys can simply copy this if you want, and paste it here maybe, all right, and maybe remove this. Actually, I don't need this anymore, and remove that too, and that's pretty much it. So what's happening here? So here we're calling, actually let's delete this, again double D to delete the cell. And here you will find train test split. And here we're passing along our X, which is our input, our Y, which is our output. Here our test size, 0.33. So that means, let's say 33% for testing, and 25%, and the rest, sorry, for training, which is around 67% for training. And then here, when we say random state equals 42, basically, if you set random state, let's say equal 42, that means you're going to be getting the exact same answer every time. So if you guys wanted to replicate basically my results here, set it to the random state 42, or you can call it whatever number. That will kind of set when you perform shuffling for the data, and any random process will basically going to be pretty much the same on your machine and my machine as well. All right, okay, so let's press shift enter. Here we go, looks great. Maybe take a look at xtrain, shift enter, and here xtrain. Okay, all right. There's actually very important kind of two conclusions, okay? The first conclusion is, or the first observation is, here we have xtrain has 335 rows, which makes sense because that's kind of, the 70% almost of the training data, which makes sense. The second point is you'll find that the index here is kind of shuffled. They are all over the place, right? Which is a good thing too. Why? Because in general, when we perform machine learning, we would love to actually shuffle the data. That will ensure we're going to avoid what we call it overfitting, and will ensure our model will perform generalization. We'll be able to kind of provide better results to data that hasn't been seen during training again. All right? Okay. So that's kind of xtrain. So if you guys take a look at it here, it looks good. Let's take a look at xtest. So xtest. Shift enter. You will find again the data shuffled, which is good, and you will find that here the data has 165 rows, which makes sense because if you sum up 165 rows plus for testing plus 335 rows for training, we'll come up with our 500 samples, which is the overall number of samples. What you could do as well is you can say, okay, I will take x underscore train dot shape, shift enter. And that should tell us, okay, that's the shape 335 by 1. And you can take a look at xtest.shape as well, shift enter. That will tell us 165 by 1. If you want to take a look at ytest, maybe start with ytrain first, .shape, which is my target, shift enter, 335. And please, you have to make sure before running any training, linear regression, logistic regression, whatever, you need to make sure that this dimension is basically equivalent to this dimension. That means for each of the input training points, we have an equivalent output for our training data points as well. Similarly, if we take a look at y underscore test shape, you will find that here again we have 165 samples for the output during testing, which is equivalent to our X test as well, which is our inputs, which is 165 as well. That means the model should work, no problem, and it should be okay. All right, so now it's time for a quick challenge. What I want you guys to do is to divide our data into 20% testing and 80% for training. Please go ahead, pause the video, and I will see you guys after the challenge. All right, I hope you guys were able to figure out the challenge. What I ask you guys to do is to simply divide the data set instead of 33% and 67% into 20%. So here I just set it to 0.2 simply, that's all what it is. So that would be 20% for testing and 80% for training. To run the cells, shift enter, and then shift enter, shift enter, shift enter, shift enter, shift enter, and here we go. So if you guys take a look at it here, you will find that that makes sense too. So now we have 500 samples. We divided them into 400 samples for training and 100 samples for testing, which makes complete sense. If you sum them up, you will come up with the 500 samples in total. All right, and that's pretty much all what I have for this lecture. I hope you guys enjoyed it. Let's recap what we have done so far in this lecture. We have been able to kind of prepare our data set to perform the training. So I've been able to import our train test split class and actually do the splitting here into 80% and 20%. And we'll be able to have our data set pretty much ready. X train, X test, Y train, Y test. Again, inputs during training and testing, outputs during training and testing. And that's beautiful because now we're pretty much ready to go ahead and actually perform the training. All right, in the next lecture, I'm going to walk you through how can we train a linear regressor or using linear regression mainly to obtain the relationship between the temperature and the revenue, and we'll be able as well to visualize our coefficients. Please stay tuned. You are getting better. You're getting closer to the actual goal. Best of luck, and I will see you guys in the next lecture. Hello everyone and welcome to this lecture. In the previous lecture, we have been able to use our train test split to actually split our data into training and testing. All right. In this lecture, I'm going to show you how can we start training our model. Okay. Actually, you will find that using scikit-learn or sklearn, it's actually very, very easy to use linear regression and to model whatever model you want in a very couple of lines of code. All right, let's get started. So what we could do, we could say, okay, from sklearn, okay, dot linear model, linear underscore model, we're going to import linear regression. Okay, so what we're going to be doing here, we're going to import our linear regression class. Okay, the next step, and that's kind of a standard. Okay, these three lines, actually going to be using them pretty much in every single classifier. Okay, or any single, let's say, perform multiple linear regression, or let's say polynomial regression, or whatever regression, we're going to be able to use pretty much the same codes, just a very simple change in it. But that's the overall idea. We're going to import the class first. The next step is we're going to instantiate an object out of this class. All right, so what do you mean by this? So we're going to say, okay, regressor equals to linear, and actually if you press tab, it should auto-complete for us. So linear regression, which is simply what we imported here. And what we could do here, open parentheses, and then say fit underscore intercept equals to true. All right, what do you mean by fit intercept equals to true? When we say fit intercept equals true, that means you are asking kind of the linear regressor to obtain the two parameters that we referred to. We wanted to obtain the slope, which is m, and the b, which is our y-intercept. So when I say fit intercept equals true, that means I'm asking kind of my linear regressor to assume that there is a y-intercept, okay, that there is a b value to return. If you set fit intercept equals to false, that means there won't be b, there won't be b value. That means the y-intercept will be set to 0, okay? So the only value you're going to be returning is only the slope of the line. And that means that the line has to go or to pass through the origin, okay? And actually that will be part of the challenge. So please go ahead. First, we're going to use fit intercept equals true and run the model. And then in the mini challenge, what I'm asking you guys to do is to simply try to set fit intercept equals to false and compare the results. But we're not ready yet. Let's keep going. So let's press shift enter. Here we go. Now we're good. And now to the third step, what we're going to do here, we're going to say, okay, now let's obtain our regressor. And we're going to say dot fit, and we're going to pass along our training data, which is our x train y underscore train. All right, and that's again, please just try to recall or remember these three lines. We're going to be using them pretty much everywhere. So we're going to import our class, instantiate an object out of this class, and then use the fit method on our object, on our regressor, and pass along our training data, which is our x train and y train. And that's it. After you run this cell, now you trained our model. Now you ran an optimizer in the background, and you were able to obtain the coefficients m and b. All right, let's see them. Shift enter. Here we go. Here we're saying, okay, fit intercept equals true, looks good. And now that means the model is trained. All right, let's go ahead and actually visualize our model. So if we say, okay, print, I actually need to visualize my slope m and my y-intercept b. So I'm going to say linear coefficients m, okay, which is my slope. And what I could do here, I'm going to say, okay, I can pass along our regressor, which is again here my regressor, my object here, which is my, think of the regressor as kind of my trained model. All the information within our trained model is contained in here. If I say dot coefficient underscore, that should obtain my slope m, okay? All right, actually let's copy that and let's paste it here. And I need to obtain linear coefficient. Actually, let's make it linear model coefficient. Here I call it linear model coefficient. And instead of m, I'm gonna pass b. And here, if I say I don't need the coefficient, I don't need the slope, I actually need my intercept as well, which is my b value. All right, okay, that's pretty much it. Shift enter. All right, and that's basically our model. These are the two parameters that I've been looking for throughout the project. So what I've been looking for is to simply our slope, which is 21, and our coefficient, which is 46. That means that my straight line, if we go up here, more, we'll have a lot of information. So that means that beautiful straight line in here, okay, the best fit straight line, obviously not this one. Here we're talking about, actually, let's go up here, all right? This is when the temperature versus revenue. You will find my slope, m, was around 21, which makes sense because that means it's positive, which makes sense because as temperature rises, you will find that the revenue rises too, or goes up as well. And if you take a look at the coefficients, b, which is the y-intercept, you'll find that we intercepted the y at around, let's say, 43 approximately. Again, this line, this is not the best fit line. This is just, we're using lmplot to just obtain kind of, the line in there. But this is not necessarily what we have been doing here, okay? Here we're actually using, like least square to try to fit our best fit line. And that's what I've been doing here when we apply the fit method on our regressor, okay? All right, so now that's pretty much how can you actually run the model and train our model, okay? And what I want you guys to do is to please go ahead, pause the video, and try to set fit intercept equals to false, which is again, that means our b value should be set to 0 and the line has to pass through the origin, okay? Please go ahead, pause the video, and I will see you guys after the challenge. All right, hope you guys were able to figure out the challenge. What I ask you guys to do is to set fit intercept equals to false instead of true. So you press shift enter, here we go. All right, so if you guys take a look at it, you will find that our coefficient here, which is our y-intercept, has been set to 0, which makes sense, and our slope was been set to 23, okay? All right, that's great. That means my line would be forced to go through the origin. All right, okay, and that's pretty much all what I have for this lecture. I hope you guys enjoyed it. In the next lecture, we're going to go ahead and actually perform testing for the model and actually visualization of the model too. To be very, very interesting, very, very exciting. I hope you guys enjoyed it and see you in the next lecture. Hello everyone and welcome to this lecture. I'm pretty excited because in this lecture we're going to do amazing stuff. We're going to actually visualize our data. We're going to test our model. Let's recap what we have done in the past. In the previous lecture, we have been able to train our model. So I've been able to import our linear regressor, and we've been able to actually train our model as well by instantiating an object here and using the fit method by passing along our x train and y train on our regressor. And then we've been able to visualize our m value and b value, which is my slope, and y intercept. All right. If you guys recall here, we set the fit intercept equals to false. Let's go back and actually set it to true, because now I need to test my model assuming that I have the two parameters. So now I have actually two parameters, which is my m, which is my slope, and my y-intercept as well. All right, so let's see how can we test our model. Okay, so what we could do, okay, we can go ahead to my regressor. If you guys recall, our regressor here, that kind of contains all the model, all the intelligence is contained within our regressor object. So we're gonna say, okay, regressor, if we apply the predict method on our regressor, and pass along our x test, which is our testing data, that should generate my, what we call it, y predict. Okay, so what happened here? Here we have our model. So this is simply our trained model, y equals to mx plus b, with known parameters, these parameters. Now I have m and b. If I apply the predict method on our regressor, and I pass along our x test, which is our testing data, okay, then the model will simply run and will give me kind of the predictions. What's the y predict, okay? Let's actually, before running this, let's maybe visualize our x test. Okay, so if you guys remember x test.shape, it was 100 by 1 because we divided the data, 500 samples, into 400 samples for training and 100 samples for testing, right? Okay, so if we take a look at it, maybe take a look at x underscore test, shift enter, here we go. That's simply our data points, okay, just to, like, you know, random sample data points, 100 rows by 1. What we did here is we simply ran the model. We simply, for each of these data points, okay, we went in here, we ran the model, simply we substituted in the equation y equals to mx plus b, given the values of m and b, which is our predicted values that we have been able to, or optimized values that we've been able to obtain. When we run that, that will give us kind of new predictions. Will give us, okay, I pass you, I give you the temperature, and here you are predicting the revenue. That's kind of the predictions. So actually press shift enter. If we take a look at y underscore predict, here we go. These are kind of the temperature the revenue predictions. These are the dollar value predictions out of my trained model, okay? Okay, so if we are lucky, if everything goes smooth, if everything goes amazing, that means y predict, which is my model predictions, are actually exactly the same, exactly equal to my y test. If you guys remember, we had our x test and y test, right? So y test was the true actual outputs. Y predict is what's coming out of the model, if you guys remember. So if let's take a look at y underscore test, shift enter, here we go. This is our basically kind of, you know, true samples. This is the true measurements out of our data set, okay? So now we're pretty much ready to actually go ahead and maybe visualize everything in one graph. All right, so let's go ahead and actually visualize our data. So what I'm gonna do here, I'm gonna do mainly two plots. I'm going to plot our training data points, which is our 400 data points, along with that straight line, which is the best fit line. And what I'm gonna do as well afterwards, I'm gonna plot a new graph that shows our testing data points too. So simply, I'm gonna just visualize 400 points on their own, along with a line, and my 100 points, which is my testing data sets, along with my straight line as well. So let's see how can we do that. We're gonna say, okay, plt.scatter for scatter plot. And here I'm doing the training first. We're gonna say x underscore train, and then y underscore train. And here I'm gonna specify the color equals to whatever. Here I'm gonna call it gray, for example. Shift enter, here we go. So now I've been able to actually on the x-axis to visualize our temperature. On the y-axis, I can visualize my revenue, let's actually do that. Okay, so what we could do here, we can say, okay, plt dot y label, and here I can pass along simply my revenue, which is in dollars, and I can say plt dot x label. I can here pass along my temperature, which is in degree C, right? And again, maybe do a title. So plt.title, I can pass along, write whatever I want here on the title. I'm going to say, okay, this is my revenue generated versus my temperature at my beautiful ice cream stand. And here I can maybe specify, this is for my training set. This is the training data, because here I'm plotting the X train, Y train. Shift enter, here we go. So now I have my x-axis, I have my temperature in degree C. On the y-axis, I have my revenue in dollars. And here I have my revenue generated versus temperature at my ice cream stand. All right, that's great. Okay, so now to the fun part. Now I actually wanted to visualize my model. I wanted to see what's like, you know, what does the line look like? Is it this direction? Is it this direction? What's the deal? So let's see, how can we do that? What we could do, we can say, okay, plt.plot, and here I can pass along my x train, which is my inputs. All right, so I'm going to use all the points x train. And what I could do here, and that's very important, I'm going to use my regressor, which is regressor, and I'm going to use the predict method, and I'm going to pass along my x train data. And here I can specify my colors equals to red. All right, so the question is, what happened here? What we have done here, if you guys remember, I have my model. Why my model is y equals to mx plus b. And now I optimize the model. So I have my m and my b parameters. What I did here, I said, okay, let's go ahead to my model. Think of regressor as my model. I apply the predict method using my x train, which is my input data, my 100 samples, to simply get me my predictions. This is what we call it y train predictions, using the training data. All right, and basically plot a straight line, because I said plt.plot, not scatter, between the x train and the best fit line that goes through them. Shift enter, here we go. So that's my straight line here highlighted in red. Looks great, looks perfect. And that's kind of the best line that can go through the data using the least square method. All right, sounds great. So what I want you guys to do as a mini challenge, I want you to basically repeat pretty much the same exercise in here, but instead of using the training data, I want you guys to use testing data, okay? So again, we're gonna plot, please make changes. Maybe you're gonna make a change here. Maybe you need to make a change here, and you need to make a change here and here, and maybe change the color if you wanted to. Please go ahead, pause the video, and I will see you guys after the challenge. All right, I hope you guys were able to figure out the challenge. What I ask you guys to do is to simply copy this. So we're gonna copy it, and we're gonna come here, paste it, Control V, and simply put, we're gonna say, okay, I don't need to deal with the training data. I actually wanted to do testing data. X test, Y test, maybe the color, I will set it maybe to blue points. And maybe here, I'm gonna set it, let's say, to black lines, something like that. And here, what I'm gonna do here, I'm gonna pass along my X test. So I'm gonna here, instead of train, I'm gonna pass along test. And here, I'm gonna pass along test as well. When I apply, the regressor is the same, right? So I'm gonna use predict. I'm gonna pass along X test instead of X train. And here I'm gonna have on the Y label, I have my revenue in dollars. My X label, I have my temperature. And here, instead of training, I'm just gonna call this testing. All right, shift enter, here we go. This is my beautiful line. So this is basically my line when it comes to testing data set. All right, so first of all, you will find that the straight line, which is the model we obtained, is actually pretty good for both training and testing. All right, that's a good observation. The second observation is the number of data points here are actually fewer or less compared to these points, which makes sense because here during training, you're actually using the majority or the bulk of the data set. You have actually used 400 data points. However, here we only used 100 data points only. All right. Okay, that's again another good observation. The second observation is is that, okay, let's take a look at that straight line. Does M and B make sense or not? Let's go up here. If you guys remember, we have been able to, in the previous section, to obtain my coefficients here. So I was able to obtain M, which is my slope, was 21.3, and I was able to obtain my B, which is my y-intercept, which was 46. Let's go here and see if that makes sense or not. First of all, the slope was positive, which makes sense. That means as temperature rises, as temperature goes up, our revenue in dollars goes up too, which makes sense. Okay, that's why the slope M is positive. The second observation is, as we go here, maybe if we extend that line here a little bit, it makes sense that we actually hit around 40, for example, which is my B, which is my y-intercept, which is around, let's say, $40 approximately. Okay, so that makes complete sense. Now to the mini challenge. What I want you guys to do is to simply repeat pretty much the same exercise, but please go ahead here, and instead of, when you train the model, instead of using fit intercept equals to true, which I mean I need my M and B values, I wanted to set fit intercept equals to false and see what impact would that going to have on our M and B, along with our visualization data as well, our X-train plot and our testing plot as well. Please go ahead, pause the video, and I will see you guys after the challenge. All right, I hope you guys were able to figure out the challenge. What I ask you guys to do is to simply go to fit intercept and set it to false instead. Okay, and pretty much run all cells. Shift enter, and this is a good point first. So the coefficient B has been set to 0. That means the line will be forced to pass through the origin. Okay, looks good. Shift enter, looks good. Shift enter. All right, let's keep going. Let's actually visualize the data. Shift enter, and maybe visualize the data here too. Shift enter, and here we go. All right, so the first observation here is that you find that the line here passes actually through the origin. Okay, so you find that this is kind of 0 and 0, right? So this is basically the origin point. So the line has been forced to go through the origin, which makes sense. And here you will find that this line as well has been forced to go through the origin too, which is 0 and 0, which makes sense as well. All right. Okay, so that looks great. So what I ask you guys to do is please go ahead, set it again back to true, because we have another mini challenge. So let's set it to true. And let's go ahead and actually run all the cells again. Shift enter all the way. Okay, looks good. So now we're pretty back. So now when we are 0, we actually have around 40 values here, right? Which makes sense, okay? All right. What I want you guys to do is to simply, let's assume that I came up with a new, let's say, temperature value, okay? So I came up with a new, let's say, temperature. And let's assume my temperature value, for example, was, let's say, temperature equals to like 40 degrees C, okay? And what I wanted to do, I wanted to utilize my model as a businessman, for example. Okay, I said, okay, maybe I wanted to predict what's my revenue value given that today's temperature was 40 degrees. All right, that's actually pretty easy. I can say, okay, my revenue predictions, okay, equals to, I can call my regressor, again, think of the regressor as my model. Here, all the information is contained. Here, my M is contained, my slope, and my B value is contained as well. Well, if I use the predict method and I can pass along my input, okay, think of it as kind of substitution. You are using the temperature equals to 40, which is here, you're using 40 degrees C's to go up and come here and maybe predict, let's say, almost $900 or something. You can actually do that here. So if you press Shift Enter, if we take a look at revenue, Shift Enter, here we go. So now we came up with revenue of $902, which makes sense because the temperature is elevated. All right. So now it's time for a quick challenge. What I'm asking you guys to do is please go ahead, pause the video, and select 3 temperatures and run the model 3 times. And please show me 3 different revenue values. And please make sure that, when you go up here, you actually perform the testing and, the values matches the graph as well. Please go ahead, pause the video, and I will see you guys after the challenge. All right, I hope you guys were able to figure out the challenge. What I ask you guys to do is to simply select like 3 values. So for example, here I'm going to select, let's say, colder temperature 10, maybe room temperature 25, and maybe 35 degrees C. Let's try them all. So first I'm going to try 10. So shift enter, here we go. So when I set the temperature to 10 degrees, if I go up, I will come up with around $260, okay, which makes sense. Okay, again, as the dollar value, as the temperature drops down, that means we are in the winter time frame. I'm expecting the revenue for an ice cream stand to be low, which makes sense. If I increase the temperature to, let's say, 25 room temperature, I'm expecting the revenue to be 581, which makes sense. 25 degrees C, if I go up, I can expect pretty much 581, let's say $600. If I maybe take it to the next level and set it to 35 degrees C, shift enter. So 35 degrees C, I can go up and I can come up with almost $800, which makes complete sense as well. All right, so now congratulations. Now you pretty much have a simple linear regressor or model that you could use basically to predict, any revenue for any temperature given. Think of it that you can expand on that project and apply it pretty much on any application. So if you are working in a company, for a company, and you have any data sets that maybe change in a kind of in a linear fashion, you can try to go ahead and pretty much use the same code, just a little bit of changes to the loaded data, maybe do some data cleaning, and you'll be able to kind of create a model that will, make huge impact to your company. All right. So let's recap what we have done in this project. In this project, we have been able to develop a model that can predict our daily revenue and generated in dollars given our outside air temperature. We went through various steps. We have been able to import all our libraries in step 1. We have been able to import all our data sets, which is our ice cream data, consisting of 2 columns, which is temperature and revenue. And we have been able to here use our describe and info methods to simply kind of give us kind of a statistical summary of the data. And we've been able to visualize some of the data using Seaborn join plot here. And we've been able to, again, plot the revenue versus temperature and temperature versus revenue. And we've been able to use pair plot as well to just give us kind of a quick summary of all the data points, or all the data in one-stop shop. And we've been able to use lmplot to just give us a quick overview of the best line that can go through all the data points. And then we have been able to, in step 4, to create testing and training data set by simply dividing our data frame into xtrain and xtest. And we've been able to do that using train test split from sklearn. Let's go down. So we have been used sklearn train test split to actually split our data into training and testing. And afterwards, we have been pretty much ready to perform our training. So we have been able to import our linear regression, which is our class, and then instantiated an object out of our class. And then we have been used the fit method on our regressor, passing along our training data, xtrain and ytrain. We have been able to obtain our best coefficients, which is our M and B, which is basically our model. The next step, step 6, we have been able to test our model using simply the predict method, and we have been able to simply visualize our data for training and for testing, and we have been able to find the best line that can go through all the data points. And now, congratulations! Now you pretty much have it as like a complete, simple linear regression model, and that should conclude our project. Best of luck, and I will see you guys in the next project.
I hope you guys enjoyed this tutorial and find it easy, simple, and fun. Please subscribe to my channel for more videos, and see you next week.